Good morning, everyone. This is Atharva from Group 35. And as a part of this hackathon, we are proposing an LLM, RAG-based LLM model to tackle the diabetic food problem. So just we'll have an background overview of the intensity of this problem.
So coming to the situation and background, diabetic food diseases is a serious complications of diabetic mellitus, especially type 2 diabetes. So the advanced stages lead to ulcer and infections, which might become severe in the later stages. Many patients they are unaware of early warnings like minor numbness, heat changes, or early skin cracks, which can lead to serious complications in the end, by resulting to complication. Individuals with diabetes face around 15 to 20% lifetime risk of diseases. According to the International Diabetic Federation, around 9.1 to 26 million people they face diabetic individuals they face this DFU every year. The current challenges of this diabetic foot ulcers result in expensive and inaccessible of settings, complex procedures which is not situated for primary healthcare clinics, and also it is designed for complications which will be becoming severe after certain stages of damage.
As part of this project, we just did a survey on different methodologies that are currently used in technology to detect this diabetic foot ulcer. But everything is having their own demerits. For example, majority of them were expensive. Then other things were only detecting at the last stage of the diabetic foot ulcer. Someone was not some technologies is not directly identifying this foot ulcer, and the majority of the tests that we analyzed or that we studied were monofilament test, vibration perception test, infrared thermography, Doppler ultrasound, gait analysis, sweat gland function test, and also majority of this test requires a technical person to assess them also.
Yes. So as they mentioned about the existing things present already and also their drawbacks, we propose a RAG-based model which can help to converse with the patient related to the diseases that he has, and finally end up in a not an perfect solution, but at least giving a good approximation if the person is going to get a disease or not. So this here you see is the RAG architecture that we are targeting on. It's extension of the usual RAG architecture we see. When I say RAG, it's retrieval augmented generation, where we give say specific documents to the LLM through which it can parse, and then based on the user's queries it can respond. So RAG is seen to have increased accuracy or reduced hallucination by around 60%. So this is what we target. In our case, these documents will be various books related to diabetes foot disease, and also various research papers which target how a particular symptom can turn into whether it's a diabetic model or if it's a diabetes or not. We have also mentioned few text tracks also. This is just we have targeted everything. Of course, as we go on to actually building up the product, we will finalize the set, especially the LLMs to be used, the vector database to be used, and even the hosting and all those aspects would also come into picture. We even did an similar literature survey for existing approaches. So there was an LLM based approach, but of course it was not responding based on the user's query. It was just giving, it was more of an information chatbot kind of thing, which was giving information about diabetes and allied diseases. Similarly, another research paper which we found did a testing of existing LLMs in their crude forms, like the chatgpt.com, or even if you go directly to gemini.com, yeah, and then if you ask query, they have made a test out of that. So both the research paper we have provided in an additional information through the zip folder. So these papers will again help us to test our own model also, and build the necessary tech stack and also understand their drawbacks as well. So with this, we'll go on to the impact of our idea.
Srivashni?
So the impacts that we have are like of various types, which are clinical impacts as well as economic impacts. So under clinical impacts, we have early risk prediction and prevention. This is because the model helps in like preventing the risk for diabetes early, because we collect all the physiological and historical data of the patient, and we are able to diagnose even asymptomatic cases. And continuous monitoring is also possible through this because when we collect data over time, we can send timely alerts to doctors and patients for to ensure that they have continuous tests so that recurrence does not occur. It also helps in clinical decision support for doctors when decisions are ambiguous because this chatbot can also take in historical data and can take in various types of data and provide the decision and help in the decision that the doctor needs to make for diabetes care. Now, psychosocial support is also an important concept because people have stigma associated with diabetic food and it becomes difficult to go approach a doctor. So, this provides a stigma free platform for patients to discuss their concerns and to get real time info. Multilingual accessibility is an again important factor because we are targeting rural areas. So, we offer our chatbot in like various languages so that we offer inclusivity. Moving on to economic impacts, we see that there's cost reduction because the model is cost effective, and it also has a prevention of complication and prevents and reduction of costs. Hence, because it helps reduce recurrence and it also helps in early risk prediction. Thirdly, it also helps in policy impact because it helps us get data-driven insights to shape insurance and public health policies because we are able to get data from patients from like a particular region. It is also reducing burden on healthcare in general because the amount of time a doctor needs to cater to specific patients is very less presently. So this helps ease pressure on tertiary centers. And last thing, we also see that it helps collect rural data for better planning and for DFU management. It helps in analysis of trends in various rural areas related to diabetes.
So coming to the stakeholder analysis, patients of course are the main thing that we are targeting. Apart from that, we also feel that health institutes, various doctors and clinicians can also use it to understand about the patients itself. An important thing that we have added is the R&D team and the policy making team, because R&D team would be required for keeping the model updated same way, because not just the tech part, that is the LLM part, but even there would be research going on related to diagnosing this particular disease. So this LLM should be kept on regularly being updated with the recent trends that have been discovered in this particular disease. And policymakers also, not directly but indirectly, be act as a main component of this thing, because when it comes to LLMs and healthcare, having the right policy just to guide the patient and not misguide the patient is necessary. So with this, we target these three stakeholders in particular. So we proposed to complete this project in 5 steps, with starting from actually collecting the data, which would be used as a RAG model, then finally building an LLM onto it, and then trying out different LLM models or maybe a multi-model approach as well. Then finally making a good UI UX to this particular thing to make it completely hosted as an service, as a software as a service for any patient to use. So with this, you have seen that for this diabetic foot disease, we propose an additional method where an LLM approach, which we have seen not has not been directly implemented as such. So yeah, we don't target to replace doctors, but rather we uh, target to assist doctors in whatever way we can, and hence help the world to fight diabetes. Thank you.